Hello, my name is Nehemiah Shannon, and this is my video 3 submission for ME 210. This here is the video of my experiment. I released a mass from an elongated spring. System that I created to pull on the spring. This was made due to the small size of the spring and the inability to test it with my hands for the desired results. Length of the system connected to the spring. The system connected directly to the spring was about 9 inches, while the system connected to that system was about 12.7 inches, totaling out to around 21.7 inches, which is about 1.808 feet. Length of the spring stretched versus unstretched. When unstretched, the spring was about 0.75 inches, or about 0.0625 feet, and when stretched, the spring was about 0.9 inches or 0.075 feet. The time the string was stretched and the time it took to snap back to normal, though a little off because the initial time was taken at 12.26 seconds. The time shows that it took about 0.4 seconds to go from stretched to unstretched, but as you saw before, the video was in slow-mo at 120 frames per second, so when converted to the regular speed of 30 frames per second, the time was about 0.1 seconds. For this problem is that the system's length is about 1.808 feet, the mass attached to the spring is about 0.97 pounds, the time it took for the spring to go back to a normal state was about 0.1 seconds. What we are assuming / neglecting is that in this hypothetical, the system that is connected directly to the string is massless. The system is also a singular outstretched system despite the fact that the system is not one singular string. The system is a particle and g is equal to 32.2 feet per second squared. What to solve for this is finding the spring constant of the spring. This problem is realizing that I am using conservation of energies and think about the components within the system. In doing that, I can say that my energy at the beginning of the reaction is the same at the end. With this information, I can say that there is no kinetic energy at the beginning of the reaction because there is no velocity, but there is a spring constant with how much of the spring is stretched. Then, once the reaction is had, you'll be able to find the kinetic energy at the end of the reaction due to the velocity of the spring going back to its original state, and that velocity can be found with the given time and distance. Then there is also a spring at the end of the experiment. With all this information, you will have all the variables except for k, and that will be your spring constant.